Hi, my name is Cedric Singh. I'm a cloud software architect with a focus on confidential computing at Intel Corporation. In this video, I will showcase a demo of attesting to secure workloads using Intel TDX attestation capabilities. In the realm of confidential computing, ensuring the integrity of protected software and its runtime states is paramount. However, this task presents a formidable challenge without the use of cryptographic evidence, commonly referred to as attestation. Attestation serves as a means for verifying the legitimacy of software, which is essential for secret owners to assess the trustworthiness of the software before entrusting it with sensitive information. This slide further illustrates the concept. Say I have my client connect to some service in the cloud and I'm prompted to provide my secret. But wait, is it safe to provide my secret to the server? To answer that question, I'd like to know if the server was started from the expected binary image, if it is running on top of good system software components, and if the whole system is protected by the hardware that I can trust. Intel Trust Domain Extensions, or TDX for short, can solve the problem. TDX offers a secure isolated execution environment known as trust domains, or TDs for short. Each TD features static and runtime measurement registers for attesting to its initial states and ongoing events, like loaded modules or invoked APIs. Attestation allows the assessment of the legitimacy of software within the TD. Next, we are going to see the demo that uses Intel TDX to protect a container and attest to its integrity and the origin of a secure message from the protected container. This demo uses a container software stack called Attested Containers, or ACON, which is an open source project developed by Intel. This slide describes the components and software flow in the demo. The big blue rectangle in the middle is a TD. Given that it is hosting the ACON stack, it is referred to as the ACON TD. The ACON TD is a minimal TD booting with just the Linux kernel and a single user mode process called the ACON daemon, or just ACON D for short, which is the yellow box. ACON D provides APIs to allow host software to manage containers inside the ACON TD. To start a container, its image is fed to ACON D, which then measures the image and records the measurement in an activity log, and then extends the log entry to a hardware-protected runtime measurement register, or RTMR for short. Now the container is ready to be started. The container in our demo is a very simple server application that listens on the TCP ports and returns an attestation to every client that connects to it. The attestation is a set of hardware-signed values expressing the security state of the container and its environment. From the attestation, a client can inspect the launch time and runtime values, like the cryptographic identity of the container. Now, if we run the client and if everything works out smoothly, the client will be able to verify that the security states expressed in the attestation meets the client's security policy and that the message attached to the attestation is intact, and finally print out the hello message from the server. Now let's start the demo. What we see here is a Tmux window split into multiple panes. We run the same server container in 3 different setups, and their outputs are in the 3 panes on the right, respectively. In the first setup, the server container is running in a regular VM, and its output is shown in the top right pane of this Tmux window. Now let's run the client. As the legacy VMX doesn't support attestation, the server failed to get an attestation as expected, and the client had to abort. In the second setup, the server container is running inside the TD, with its output shown in the mid-right pane of the Tmux window. Let's run the client again and see what will happen this time. From the server's output, we can tell it has succeeded in getting an attestation, which is called a quote in TDX terminology, from the underlying hardware. The client was also able to verify the quote, but it failed the security policy check this time. What's happened is that our client enforces a security policy demanding the server as the sole container within the ACON TD. The RTMR log is inspected for a specific finalized entry, which would indicate the ACON daemon had shut down its API to block further container image loading. Unfortunately, ACON TD didn't shut down its API in this setup, and the absence of the finalized entry was detected by the client. In the last setup, the server is also running inside the TD like in the second setup, but we finalized the ACON TD this time after launching the server. After running the client, we can see all tracks have passed, and the client has printed the hello message attached to the TD quote by the server as attestation data. In summary, Intel TDX attests to the TCB of a TD using a TD quote. The quote includes digest of the TD's initial state, the RTMR log, and additional data provided by software during quote generation. In our demo, the initial state signifies the TD booting with the ACON stack. The RTMR log verifies the server's launch from the specified container image and confirms it as the sole container in the TD. The attestation data digest serves as a proof of origin for the hello message. This concludes our demo. More details on ACON and workload attestation are available at github.com/intel/acon. Thank you for joining us.